Hello friends, welcome to Master of None. First of all, I want to say that my English is not so good, so please forgive me if I speak something wrong. And moving on to the explanation, uh, it may be difficult for me to explain in English, but if you have any issue, then please comment. So we are going to work on a lots of mathematical functions and all. For example, related to graph, that is the xy coordinates in 2D dimensions. So if it's better, you know a little bit of maths. So let's start. Here we have the main function. Uh, what exactly a game contains? A game contains a game loop. First of all, the game loop that will repeat our frames one by one. And inside this game loop, what we're gonna do? We have to first draw everything that we want to draw. So first we are drawing whatever we want to draw, and then what we are going to do? Then we have to update our changes, like for example, updating player, and then we will display it. So basically, we are drawing it on the canvas and then displaying the canvas. So drawing and displaying is not the same thing. Then that's all what we are going to do. So first of all, what we will do, we will draw, then update, then display, and then repeat. This process will be repeated over and over. So for this we have set a sleep time, that is a 30 millisecond of delay that I have stored in a constant. So what happened every time, each frame, this is basically a single frame. A loop cycle is a single frame. So in a single frame it will wait for 30 milliseconds and then will jump to next frame. So this is what is exactly happening. So why so 30 millisecond delay? Because different computers have different frame per second and can provide a better efficiency. So it will result in an uneven frames. So what we have used the frame delay milliseconds. So the sleep will just wait for 30 milliseconds after every frame, and that manner we are going to have a consistent speed during the game loop. So let's go on to some details. And one more thing, we are using the default console of the output screen and a Dev C++ compiler. For this to work, what I have used is a command to clear the screen. So basically what happens whenever we print all the stuff into our screen and we again try to print another frame, we are just using cout to print the stuffs. So if we again use the cout to print all the stuff, so it will just scroll up, and we don't want that. We want it to be like a real frame, which is basically replacing the old one, overriding the old one. So for this, what we have to do is to clear the screen first. So we will clear the screen first and fill it with the default elements that we want. For example, we are filling it with a dot for initially. So we will be having some sort of dots, like for example this, as you can see here in the screen, I have some grass over here. This is what grass look like, and here is our road, and here is our another grass. So what we are basically doing, we are just printing all these symbols one by one, just like in a matrix. So first of all, what we have done is we have stored everything in a matrix of around the windows width, and then what we have done, we have just print that particular matrix. And after printing all this, and the next frame, what is going here is this matrix, this particular image is completely wiped out, and again a different image is printed with the updated code, with the updated symbols. So the updated canvas will have updated things, like for example the car is moving here, so it will have the updated car over here, and similarly. So what we are basically doing here, we just clear the screen, and in the header section we edit our score, and then we just fill the screen with a dot, and then I have replaced the other part with the grassland, that is this part. I have replaced this part, filled this part with the grass, and this part with also with the grass. And then we have a draw enemy. For enemy, I have created an enemy class. I will show you later. So using this enemy class, we are drawing our enemies, that is this enemy we are seeing. And after drawing the enemy, what we are doing, if we are checking if the difficulty is greater than 50, and then we will draw another enemy. So basically below the level 50 you will have only one enemy. After 50 levels you will be having two enemies. Then what we are doing is using we are drawing our player. So here our player will be drawn. Then after that we are just displaying everything. So everything we are drawing is just being stored in a buffer, in a canvas. Okay, so it's not being displayed before we display it. So to display it, we are using the function display ASCII, and it will display all the functions here, all the symbols here. Sorry for that. And then for collision detection, I have used this. So what basically I am doing, I have declared a function check collision, and here is our player P and even enemy, and we are checking if there is a collision between the player and the enemy, and or there is a collision between our player and the second enemy. Then what we are going to do is to break our game loop. We are setting running equals to false and breaking the loop. So what happens, the break will call and it will come out of this loop, and then finally our game over will be printed. So this is the basic main function, how it's going, the flow of the game. And now let's go deeper in the things of how exactly the things are being drawn. Canvas part that I have made. For the canvas, I have taken a width and the height, and the width and height is basically telling you what exactly is the number of symbols will be in the rows and the columns. For example, here I am having almost how many? Okay, so in the width I am having almost 40 symbols, and in the height I am having 20 symbols. So here I am using constructor to initialize this. So width, for the width we are having the 40 symbols, and for the height we are having the 20 or 30 symbols, maybe 20. And then after initializing it, what we are doing, we are using a buffer. So what exactly buffer is doing, it's a linear vector storing all the characters. As we can see, this is storing all the characters, and basically this all is being stored in this buffer, and this all characters is being stored in this buffer. And what we are doing is setting its size to width into height. So basically this every row of this is being stored in this buffer, and obviously if it is 40 and its height is 20, then if we multiply both, we will get the total number of symbols that can be present in this buffer. So we have resized it with width into height. Then we have the clear method. Then we have the clear method. What is basically, I should have named it fill. So it is doing nothing, but it is filling the canvas with the default symbols. For example, here I showed you that I have used the dot symbol. So it is filling the canvas with the whole buffer with the dot symbol. So after that we will be having 40 cross 20 matrix with all of the dots. So here we will be having all the dots, nothing else. Then we have implemented a method that is called a set pixel. We have implemented it. It takes the position x coordinates and the y coordinate and use that to fill the buffer. So what exactly happens? It checks for if it's not out of the bound of the matrix, then it will fill the buffer with that particular character. So we are just storing the character on the buffer. Here, for example, I have to fill the particular x in this spot. So what I'm gonna do is select its coordinates. For example, from x it's maybe 15 or something, and from y it's maybe 5 or something. So I was just going to say x equals to 5 and y is equals to this. X equals to 5 and y is equals to 15, and add a symbol over here, the character, for example x, and this will check if it's not out of bound, which is in our case is not, and will store the particular character in the buffer at this location. So this is how we are setting our drawing our pixels. So it will just store it. It's not going to print it. Just store it in the buffer, in our buffer. Okay. Then we will be having a get pixel method. This is to check for the particular coordinate if it is having what kind of pixel. For example, here we have a x, so we will check this x coordinate and y. Then we will get the x character. It is showing that what character is present in that particular coordinates. Similarly, if we go here and put the x and y, we will get the pixel of that particular location. So this is all for the drawing logic, and for displaying everything, just I am looping over the canvas, that is the buffer, from 0 to the height and from 0 to the width, and just taking out every character from the buffer and printing it. For the width, I am just printing it directly, and after every row we are just printing an end line, so we get this effect. So we are printing every character here, then after the next row we will just put an end line, so it will change the line, and so on, print everything. Let me show you a little example. Here you can see, as I told you, if you can see it clearly, what exactly being done is it is drawing it. Oh, I lose. Wait a minute, I should start it again. So as you can see here that it's drawing it again and again, and when I click A and D or W or SD, it's just moving the particular car and updating each frame. It's drawing everything again and again and again for each frame. That's how we are updating our changes. So when I click W, it's just store the position of the player on different coordinates, and our player is moved to the different coordinates. And this is what is being done with the car as well, and this is always being drawn again and again. And when we hit a car, for example, let's hit a car. So when we hit a car like this, and this game loop overs, it will break the loop, and we, as I told you, we saw the game over here. It's basically printing everything, storing it into the updated stuff into the canvas, and printing it, and clearing everything, storing it into the canvas, printing updated things, and so on. It moves on like this. So basically it stores things, stores these characters into the canvas, and then it prints it and then clears the screen. Then what again it does is update the coordinates whatever is needed, and stores whatever it is updated into the canvas again, and then print it. And this is being repeated over and over. So we see our updates, and each frame is loaded 30 milliseconds, so it is waiting for 30 milliseconds for each update. So okay, that's for the basics. So we were talking about the canvas, and the canvas is basically doing all the stuff for printing the character onto the screen. This is how we are going to display our things on the screen. For printing the enemy, I have to make sure that the enemy location should be on the coordinates. So what I have done, I have made some properties. For example, the position of the enemy on the x coordinates, the y coordinates of the enemy, and similarly the width of the enemy and the height of the enemy, and the character for which we are representing enemy. Then we have the enemy constructor, which initializes its x position and y position, and its width and height is by default I initialized it with the entity size, that is 3 in my case, and that's a constant. And then I have initialized the character with the enemy character, that is x. I have stored it on above. Then I have actually made every property of this as private. So what I got to do is to use the getter setter for getting those positions. For getting those positions, I have made these methods. For example, get the enemy position on the x, get the enemy position on the y, and get the enemy width and its height. Similarly, get the enemy pixel. So it will return basically the character of the enemy, that is our x character. Yeah, we actually don't need this. So what we have is a draw enemy method. It's what it does, it is used to draw the enemy, and it also contains the enemy movement logic. So how it's exactly drawing the enemy, let's see. So what we are doing over here, if I show you the matrix, let's take an example. Assume our enemy is currently these two blocks. This is our enemy, and what x and y is representing is this position. From here it is drawing the enemy over here and over here. So from this position it will draw this pixel and this pixel and this pixels. So how exactly it will be drawn? So what will happen when we move to this position? For example, x will be r1 and y position will be 1 as well. So what are we gonna do exactly? We will just add this x with some sort of value. So this is basically x, and this is incrementing in x direction. So this is representing x and this is representing y. And what we are trying to do in this position for the enemy position, so this position will be ex comma ey. This will be the enemy's position, ex and ey. And from this position ex, we will add the enemy size. So we will get something position, like for example its value is here 1, and if we will add the enemy size, that is in case is 2. So if we will add 2 to the 1, we will get the 3. So 3 is pointing basically to here at this coordinate. If we keep the y same, so we go from here to 2 just before the 3, and we will just put x over here symbol in our canvas. Similarly, when the y value is updated, the rows value. So for example, here the ey value was 1, and the size of the enemy on the y direction was exactly the height of the enemy was 2. So we will add the height of the enemy and we will get the 3 again. So we will go till 3, and like for example 1 and 2, and we will fill the x enemy over here as well. So this is how we are going to draw our enemy, and that is what is being done over here. Let me show you in the code. So what we are doing, we are using a relative y position going from ey to the current, that is the current position in the y direction, y coordinates of the enemy, and adding that y coordinate with the height of the enemy. So we are going from the relative y position, that is the y coordinates of enemy, to the enemy coordinates plus its height. And on each coordinate, for example, we are in this, so from this we are going to add 2. For example, the height of the enemy is 2, then we are going from here, then we go to here. In this particular row, what we're gonna do, we will go from the x position of the enemy to the its current position plus the width of the enemy. So basically width of the enemy, as I said, is 2 in my example. So what we're gonna do, we will first looking at this, and we will go here, put the x over here, we will go in the second position, we will put the x over here, and here our condition for the loop gets false, and it will move on to the second loop. So it will update the y with the it will update the y position and increment it, and then we'll move to the next row, and similarly it will fill it with x, it will fill it with x, and this is how we are going to draw our enemy. And finally, so we are actually storing it in the canvas. So it is the canvas, and we just store the x symbols on this matrix kind of stuff. It's a linear buffer. We have converted it from matrix to a linear buffer. So it will be stored in this manner, and after when we use display, it will just print it directly onto the console. Okay, let's move on to the movement logic. So in movement logic, what we are doing, first of all, we are implementing the y coordinates of the enemy with just 1. Why so? Because for example, I said this is the position of the enemy, we are representing it, it's start here. So if its y coordinate is currently 1, so if we increment its y coordinate after each frame, for example, the one frame is render and enemy is over here, and after next frame the y coordinates will be 2, so the enemy will be rendered just after, because its y position is updated, and we again draw the enemy, then it will be drawn over here. So canvas, in canvas the x will be stored in this position. So it basically updated the position of the enemy on the next frame, and again when the y will be incremented to 3, it will move on and go to the next frame, and it will be drawn over here, and every thing out of this will be cleared, because we are clearing the frame every time, as I said earlier. So this is how we are going to update the enemy. And one thing I noticed is that let's clear it. When the position of the y coordinate will become 4, then what will happen, that it will particularly render, it has to display it over here. So it will have to set x over here, then it will look for this coordinate, and which is not actually present. So it will cause some issues. In order to prevent these issues, we will make sure if the value of y reaches the canvas end, then we are going to we do not have to do anything, we just have to skip this. So for this particular check, what I have done is exactly over here. So we have just reached the end of the canvas, so we have to make sure we are not storing on that location, because we cannot store out of the matrix and it will create some issues. So what we have used a check for this, if it is inside the height of the canvas, then what we can do is we can store. If it is not, we are skipping those parts. And in the movement logic, again we are doing this kind of check. It is for checking if the enemy is reached the end or not. If it is reached the end of the canvas, which means if it is the end of our canvas, which means we have to again spawn the enemy onto our next position. That is, for example, we have reached the end, over here, so we have to spawn the enemy again from here, and so on. We have to select x position for the enemy to spawn. For example, I have selected the x position 1, so we are going to select a random position out of the available positions. For this, I have used the random function of the C stdlib library. I can show you. This library is used to provide the random functionality. It will generate a random number using this function. So it will generate a random number, and we done the modulus of it with the right boundary minus the width of the enemy and the left boundary. So it is nothing, just a math calculation. For example, let me show you. For example, the enemy is currently present. We want to spawn this enemy in this coordinates. Okay, so we are trying to find the x position. So in order to find the x position, we have to do some modulus. So what exactly modulus does is it takes the value, whatever value a, and it will give us the value between those modulus value. For example, if I put a 5 over here, in our case there is 5 values, so we will get the output of this between 0 to 1, 0 to 4, sorry for that. So we will get the output between 0 to 4. Either we can get 1, either we can get 2, either we can get 3, and either from 0 to 4, and we can get 0 as well, and we can get 4 as well. We will never get a value equals to or greater than 5 or less than 0. So this is how modulus works. So we have used the particular width of the road here for this particular thing to check the width of the road, and it will just put the enemy vehicle x position between the road. For this, what we have done exactly here is we just use the right boundary. It is representing the right side of the enemy. Let me show you. So we have used the right boundary. This is our right boundary and this is our left boundary. Okay, so what exactly it's doing? This right boundary, it is the coordinate of this boundary. It is the left boundary and it is the right boundary. And left boundary, basically it is the coordinate of x coordinate of the left boundary, and this is the right x coordinate of the right boundary. And what we are doing is subtracting the width of the enemy from it and the left boundary. So from here to here we have the left right boundary, and from here to here we have the left boundary. So what we're going to do is subtracting this, subtracting from this part. Okay, so we are subtracting this part from this part, so we will get this road. So now we have the road, but we also have to subtract the enemy width, because as I said, here we will be having, for example, the enemy width is 3 in my case. So here, if the enemy is present over here, so we can draw 3 from here, it's fine. But if it is between here, something over here, then we cannot draw it because enemy cannot be out on the grass. So we have to subtract the width also. So it will just spawn the x position from here to almost here. So enemy will not spawn on the grass. For this, we have to make this calculation. Now we are also resetting the enemy's y coordinates to 0 because it reaches the end and we have to restart it. So it will, if it reaches the end, it will restart from a random position over here, and this continuously repeats the process. So this is all about it. And also, if the enemy reaches the boundary at the canvas end, we will incrementing the score by 1. Okay, so let's move on to player. So we have our player class. In this also we have a position on the x and position on the y, and we have the width of the player, the height of the player, that will be same 3 entity size in case, and we have the character for a symbol representing a player, in our case which is a hash symbol. And here is the constructor. We are initializing the x and y position. Let's move on to the draw player function. In this function, what we are exactly doing is, first of all, we are drawing the player. Similarly, it's the same code as we have done for the enemy. In this, we are drawing a rectangle in the enemy, and in this case, we are drawing the rectangle for our player. In the player movement, so in the player movement logic, what we got is so in the player movement logic, what we got, we have to check as we have drawn the player in the canvas. Basically stored in the canvas in the buffer over here, similarly to the enemy. Now we have to check for the player movement logic. We have used for this, we have used the Windows library. In Windows library, we had functionalities like get, async, key, state, or sleep. So using this get, async, key, state, what exactly it does? It looks for the a keyword. If we are pressing key, so it looks the state of the a key. So it checks if we are pressing a key, then it will return this particular code. So it will return this particular 0x1000 code if we are pressing this key. So if we are pressing this key, so it does the bitwise AND with this particular code, and if the resultant of this AND is equals to 1, so this condition will be true, and if it is not, then it will be false. Similarly, we are checking for the small a, and if it is true, that means it is pressing a, then we will just move it to the left and decrementing the x position of the player. Similarly to the enemy, as we are decrementing the incrementing the y position to move the enemy forward, we are decrementing the x position of this player to move it to the towards left. And why this? This is to we have used the get pixel method to as we have discussed earlier, to get the pixel at the position of the player's position -1 and on the x direction. Why? Because we are subtracting it position x minus minus. So if this particular position is the grassland position, means it's equals to a grassland character, it will return the character. If it is equals to the grass character, then it means there is a grass, we cannot move further. So okay, so as you can see, this is our grass. If we move towards it, it checks for the x -1 position and checks if it is this cave symbol, that is the grass character, then we cannot move further, so this will not run, and so it will not move further. And similarly, we have checked for the position x if we are pressing the D key, and we are checking for position x plus the width of the player. So if it is if the position x plus the width of the player, if we see a grass character, then we cannot move on the right position. Similarly, for the y it's left, it should be up and it should be down. Okay, so similarly for the up, we are checking the particular condition if the position of y is greater than 0, then only can move towards up, and if the position of y is less than the width height of the canvas minus the player height, then only we can move toward the y position. So moving further, we have also made a class for the grass length, and here also we have the x position. We don't need y because we don't need y position, just because this grass is filled completely on the x coordinates. So we are not worrying about the x coordinate, we just have to worry about the x coordinates of the grass length. So for example, this particular grass length, for this particular grass length, the x coordinate is here. So it is filling this from here to the width of the character using the g width of the grass length. So it will fill from this coordinate to the width of the grass length, and with the character which we have given, that is the grass character. Similarly, it will start from this particular x position and fill the grass according to the same width. So for this, we have implemented the method draw grassland. Similar to how we have drawn the enemy, we are drawing the grassland with the same logic and storing it into the buffer. Then we have our check collision method, which is taking the player object and the enemy object, and it is checking for the position if the player position x position plus the width of the player is less than equals to the enemy's x position. So we are checking for the position of the enemy and the player, and just checking if this two rectangle is overlapping. If this two rectangle is overlapping, which means there is a collision. If it is not, then there is no collision. We are just returning the note of this, means if there is a collision, it will return true, and if if there is no collision, it will return false. So what we are doing here, if we are checking if there is collision or not. So using the player position, for example, this is our player, it's x position, and moving towards here, the width of the player, it will add from here to here, and we are just checking if this is less than the enemy's x position. So it is checking for the collision in here. So if it is less than the enemy's x position, which means it is not overlapping on the x direction, or it is greater than the enemy's x position. Similarly, the position of x, that means this x position is greater than the enemy's x position plus the width of the enemy, enemy's x position plus the width of the enemy. If player's x position is greater than this also means there is no collision. Similarly, we are checking for in the y position, if the player's y position, for example here, plus the player height, this is less than equals to the enemy's y, means this exactly the y position of the enemy. If it is less than this, then there is no problem. And if the okay, so if it is less than this, it means it is somewhere over here, but not in here, it means there is no collision. And if the player's position on the y, that is this position on the y axis, this position, if this position on the y axis, so if this position is the y position of the player is greater than the enemy's height, the enemy's y position plus the enemy's height, means if it is greater than this, then there is no problem. So there is no collision. So this is for checking collision, and if there is a collision, it will return true. And as I have shown in the code, if it returns true, then we will break the code game loop and we will print the game over. So this is how it is moving, and again I will let you walk through this code. So first we have created a canvas object win using the canvas I have shown you, canvas class. We have set the width equals to 40 and height is equals to 20, and we are displaying the canvas by default. And then we just added the road constant for the road, for left boundary and the right boundary of the road, and we have added the player position. So it will create a P object and add this to a 19 cross 15 position. Similarly, we have the enemy setup. We have created an enemy one and set the enemy pixel is equals to the event.enemy pixel, that is X, the character. And we have also created the second enemy. So we have created the object of the second enemy, and similarly we have created the object of the grass. And this is all done, and we have set the difficulty level to 0. And then we are starting our game loop. In our game loop, we set the boolean running is equals to true, which means it will start. So when the first time the while loop runs, the game loop runs, it will clear the screen. In the header section, it will print the score of our, and then it will again use the clear function of our canvas. Basically, it will fill everything with the dot in our canvas, and then it will use the grass, and it will draw the grassland. So using this, it will just store it in the buffer, and similarly it will draw the right grass in the buffer as well, and then it is going to draw the enemy and store it in the buffer. And if we are, and then we are checking for a second enemy. If its difficulty is greater than equals to 15, then we are drawing the second enemy, otherwise we are not. And then we just draw on our player as well, and using the display ASCII method we have declared in our canvas, we are displaying everything we have drawn. So it will print everything onto our console that we have drawn using simple cout, the console out, and using this detect collision method, check collision, it will check the collision between the A1 enemy and the E2 enemy. If there is a collision between any of this, it will break our code, or if it is not, then it will increment the difficulty on each frame, and it's wait for the 30 milliseconds to complete and move on to the next frame, and this will repeat over and over until our game is finished. And finally we are printing the game over if we break out of this loop, and we are finishing our code. So this is how I made the road fighter game. And if you like this video, if you find it useful, then please check out other videos as well. And if you have some doubt on this particular video, then you can just comment down and I will just resolve it. So thanks for watching. Bye bye.